Okay, so in this session we'll be talking about scripting time series math operations, or time series operations. And the following session, the last session, we'll be talking about scripting plots. However, our data lives in DSS files, so before we can do either of those things, we need to talk about how to access DSS files within scripting. So we'll put that at the beginning of this session. And first thing we do in our script is we need to have an import line. And so the class we need to import, or the Python module, if you will, from that perspective, we need to import is called HEC-DSS, and capitalization matters. And it lives in the package named hec.heclive.dss. So somewhere near the beginning of your script, before you try to do any DSS access, you need this line in your script. Now, after you have that, you can open a DSS file name and returns you an object that you can capture to a variable. I usually call that variable DSS. You can call it DSS file. You can call it whatever you want. It doesn't matter. But you do have to capture the return from HEC-DSS open to a variable. And so you have that, and once you have that variable, you can do various things with it, and we'll see. One of the things you can do with it when you're done is simply close it, dss.close, if your variable name was DSS. Now, what is this DSS file name I have in the open, in the parentheses? Well, it's either a literal string in quotes, or it's a variable that's previously defined to have the name of the file. You will notice in here I am using forward slashes for directory separators. That is completely acceptable in all versions of Python and Jython, as well as other programming languages. Python, like several other programming languages, uses the backward slash used by Windows for directory separators. It uses that same character to have a special meaning. So if you were to have a backward slash in a string followed by any number of characters, instead of that literal backslash character, it would interpret that as something else. So when I am using directory names and file names in programming, I always use forward slashes. I suggest you do the same. There are other ways to work around this. You can use double backslashes, or you can use Python raw variables. We won't get into that right now. It's just simpler to use forward slashes in file names. Okay, having said that, the literal string there, DSS equals HEC-DSS open, quote, and then the file name. Or if you want the file name to live in a variable, you first define the variable with that same string, and then you say HEC-DSS open and give it the variable that contains that string. Doesn't matter which one you use. They're both perfectly acceptable. Using a variable name a lot of times is the preferred method, simply because it can localize where you set all your stuff. You can set all your variable names up at the top of the script, and then you have one place to go to for all that information. Okay, so that's how we open and close DSS files. So now we need to work with time series. So time series objects come in two flavors. And you'll notice that I have links here, and if you get, obviously you can't do it in the video, but if you get the actual PowerPoint to this, these links take you to the HEC-DSSVue manual, and working with here the TimeSeriesContainer. If we go back and follow the link from the TimeSeriesMath, we get the same thing. We get the put into the DSSVue manual, user's manual at that location. So why do we have two kinds of flavors? Well, we just do. And here's the difference between them. TimeSeriesContainer is only data. You think of a time series. What does it have? Well, it has times, it has values, it has quality codes, and it has some metadata, such as the units in the data type and such like that. A time series container, like I said, is just the data. It can be, the values in it can be directly manipulated. You don't have to use methods to manipulate the data. And you can retrieve a time series container directly from a DSS file with dss.get and then the time series path name. If you have a time window set, you can use a data set name, which can be a path name with or without a dpart, and it will retrieve the time series for the entire time window that you have set. But without a time window set, you can just say get the path name and it'll get a single record from the DSS file. You store a time series container with dss.put with the time series container. Okay, that's time series containers. Time series math has the data in it, but it also has operations, and you cannot directly manipulate the data in a time series math object. You can, however, retrieve and store them to DSS just like you can time series containers, but instead of using get and put, you use read and write. So there is some mental bookkeeping to keep up with whether you're working with time series containers or time series math objects, and the methods that you use to access them in the DSS file. I normally do like you see here on this slide. If I'm working with a time series container, I usually call it TSC, or if it's a flow, I've got multiple time series containers, I might call it flow TSC or something like that. If I'm working with time series math, I'll use it TSM, flow TSM, or just TSM, so that I can look at the variable name and know whether it's a time series container or a time series math. And so the rest of the info for this slide is this. TSM and TSC are just like I just said. They refer to, TSC refers to a time series container, TSM refers to a time series math. DSS is the variable that we captured the return value, the open into. Path name, like the file name in the previous slide, can be either a string literal, or a variable containing a string that points to the path name that we want to retrieve. Okay, so we have two different types of time series objects, and we can convert between them. If we have a time series math, we can call .getData on that without any arguments or any parameters in the method, and it will return us the internal data, the time series container object. So if we have a time series math, TSM, we say tsm.getData, and that returns us a time series container. If we already have a time series math object sitting around and we want to set its internal data to that of an existing time series container, we can say tsm.setData and give it the time series container, and then that time series math object will have the same data in it. So you can convert between those. Now, what if we don't already have a time series math object? Well, we can still get there, but we have to do a couple other things. So we need, just like we had to import HEC-DSS to access the DSS files, if we're going to create a new time series math object, we need to import the time series math. It's a Java class, or you can look at it as a Python module, but it lives in HEC.HEC-Math, and it's called TimeSeriesMath. So we use the import, like the first line there. Once we've done that, then we can do that second TSM equals time series math of, and we pass it the time series container. And that creates a new time series math object from an existing time series container. So you can convert back and forth between time series math and time series container, and there are different times that you need different ones. And so that's why we have them listed this way. Okay, so now let's now let's talk about scripting with these time series objects. Okay. One thing to know is time series math operations, and remember, there are no operations on the time series containers. Only time series math support the math operations. So when I said there's reasons to use one versus the other, if you're going to do time series math operations, you need time series math objects. So if you had only time series container objects, you would need to create time series math objects from them. However, once we're there, most of the time series math operations create and return a new time series math object. What that means is they do not modify the time series math object that you are using to call the method on. So they return a new or a modified time series math, and you have to capture that into a variable to be able to use it. Now, the returned object, like I said, must be assigned to a variable, but the returned object may be assigned to the same variable name, or you can assign it to another variable name. So I have examples in reverse order. I have assigning to a new variable name there in the first green check mark. TSM2, it's another time series math object. And it is the result of multiplying the first time series math object by 10. So TSM.multiply 10, capture that back into TSM2. Now you have TSM and TSM2 available in your script to work with. If you do not need both of them, you can simply capture the return of the multiply operation back into the same variable name. So we reassigned the old object to the result of the multiplication. However, you cannot do what's listed there third with the red X. If you simply say TSM.multiply 10.0, what happens is it does the multiplication and then throws the result away. and so it does not modify the original time series math. You must capture the return value into a variable. So if you're not good with, have that concept down, you can get tripped up. Okay, so that's it with working with time series math operations. Well, you say, wait, we didn't do anything. Okay, you're right. We didn't do anything. We will do something in the workshop. But again, if you have the PowerPoint, you can go to the link and jump over into the HEC-DSSVue User's Manual with all the math operations. And here they are listed out. And this says it says HEC Math up here, HEC Math class. That is the parent class of Time Series Math. So most of these are, they take a Time Series Math and return a Time Series Math. But sometimes they can also work with paired data. So if anything that says HEC Math, you can use on Time Series Math. If it says Time Series Math, you can use on Time Series Math. If it says something else, like linear regression statistics, well, then it's not really a Time Series Math. But here's all the operations, and we're not going to go through them all. We went through several of them, not in scripting. We went through several of them in the math functions or time series functions, time series operations lecture earlier. This is simply a way to use those same operations. If you remember, we had operators across different categories, and you had a dialogue in the math functions dialogue to interactively do all that stuff. Here we have all of that functionality available to us in scripting so that we can automate the time series math stuff. Again, you'll see more of that in the workshop, and we will finish up this lecture in the next session by talking about scripting plots.